Hello, everybody. So today we're going to continue with our structural class. We spoke about the concept of creating an addition connected to an existing sort of a crawl space addition, basically. And today we're going to forget about that for now, and we're going to go up into our little framing and create a roof. We're going to create a roof, how the roof framing works, and all of that stuff, okay? But for that, we're going to continue by, remember that we call this platform frame. So it means that we have to build a platform. And the next step for a project is to grab a platform like this. I'm going to copy this one twice. And building it all the way up right here. Now that we have our platform, we literally, if we have right now an attic, let's assume we have an attic right here. This is your framing for the attic. What they do often is that they either one plate or two plates, put them right here. Repeat that plate at the other side. And this is gonna be our eave side. Or eave side is where water sheds towards. So we have eave side and we have rake side. If this is our eave side, we could technically, just gonna find the middle point and I'm gonna do a random slope for the purpose of this exercise. I'm gonna pick up this. I'm gonna go up. And so what we do is that if this is gonna be the bottom of our or 2x, in this case we're gonna make this out of 2x12, which is something typical here in Massachusetts because of the R60 that we are looking for on our ceilings. If we want a hot ceiling, I mean a hot roof, so there's hot roof and hot attics, meaning if it's a hot roof, it means that the insulation is right at the ceiling, at the roof rafters. If it is a hot attic, means that it is right at the ceiling joist, okay? So in this case, we have this, and what we do is that we typically imagine that our 2x12s are gonna be here like that, but they essentially continue like this, okay? So if we have that, that's gonna be one side. And if I mirror that, to the other side, this is what it does. So this is gonna be, not like that. Let me just fill it with 0. All right, so I'm just gonna show you guys. So this is the underneath of our rafters, of our roof rafters, okay? And what they do is that if we offset this guy 11.25 inches, which is the size of our piece, this is what this is doing. It is kind of going through this, and you're like, what's going on? It's going through the plate. It shouldn't go through the plate. It's not gonna go through the plate. So this is a critical item that I always do with my projects to make sure that my roof rafters, the bottom of them, are intersecting with this top of this plate right here. All right, so another kind of, we're just establishing our roof right now. We're not sure about how this is gonna go. So oftentimes also, just for the purposes of this, they do something called a ridge board. A ridge board is something very typical when you have a roof that is essentially connected to the floor joist and to the plate, and it basically becomes a truss. So when you have a roof like constructed like that, basically this corner right here is going to be tight to the floor. And this corner right here is going to be tight to the floor. And this is going to be tight together by using the ridge board. And it essentially, if the load pushes down, it pushes this way. When this is pushing this way, this is pushing the opposite direction. And then when this is pushing this way and this guy's pushing this way, they cancel each other out. I mean, it's hard to explain, but the whole point is that they will all cancel each other out because it doesn't have anywhere to go. The floor is going to help it. Everything's tightened together. So when you do not have a condition in which you're tying these pieces together to a ceiling, you need a ridge beam and likely collar ties to help you lower the fact that this guy is going to want to buckle or push outside, and this side is going to want to push outside, and it's going to want to move your wall with it, okay? I'll explain it a little bit better in a second, but let's just very quickly do it. So 2 by 12, 1.5. 2. So it's going to be 3/4 and 3/4 in each direction because I'm going to put a 2 by 12 one here. So it's going to be 3/4, 0.75 inches this way, and 0.75 inches this way. This is going to give me my nice ridge bore. In this case, let me just find an intersect between these 2 points. Something happened here, sorry, my bad. Find an intersect in here. All right, so this right here is my ridge bore. I don't need any of that. And this ridge bore is gonna serve me as a nailer. Okay, it's gonna serve me as a nailer so that my framing of these guys can intersect. So they cut this framing in a shape like this. And what they do is that 2 by 12 piece that they did, they cut this way, and you're gonna see what happens. I don't know what happened. Oh, there you go. So it should have been solid. My bad, cap. So they cut my wood right here so that it is basically locked into this condition. You see that right there? It's locked into this condition. So you can nail it right that. Sometimes it's even more like locked into that piece. The whole point is that this wood sits right on that, like a birth mouth. You guys understand that? Okay, so this guy sits right in, locked into that, and that creates our shape for how our eave and soffit's gonna be. Okay, so that's kind of how they do that. Let me match this guy. All right, so that's that. Let me just make sure that this guy is capped. And technically, it should be a little bit longer. I'm just gonna make it a little bit so that you see. So this guy does that, then this guy gets mirrored in the other direction just the same way. They nail these two guys together. This is my ridge bore. So we nail these guys together. This is not gonna be able to move this way. You're also not gonna be able to move this way because it gets locked into this corner right here. Okay? And it gets locked into this corner right here. So all of that allows it to just remain in place. Typically, the roofs are not necessarily on 16 inches on center. They could actually be 24. They could be different distances, okay? So don't think that it has to be we calculate those guys ourselves. So we're going to be able to know whether they could be, I'm just going to copy that one and continue 16 inches on center or so. Now, there are different ways of doing this cut right here. Okay, so I don't want you to get like, well, this one is wrong. I don't know what I did there. So I did something wrong in here. It looks like, did I move him? I think I moved him by mistake before. So let me undo that. I must have been doing something and I moved him, but here you go. Let me just group him again. All right, so yeah, I know it was earlier when I was telling you they can't move this way and it can't move that way. So I moved him by mistake. But long story short, this guy comes in here at about 16 inches on center or 24 inches on center, depending on what it is that you have calculated. They nail them all in there. Okay. These guys are nailed all the way in here. Okay. And let me just show you. They call that bird mouth cut on roof rafters. Okay. You see that right there? Let me show you some pictures. You see that right there? That's what I just showed you. It is to tie the roof rafters to the top plate on your wall. Okay. In my case, I have my top plate sitting on the plywood because that attic may eventually be finished. But there are cases where there's not. If it is cathedral, you would immediately understand it, right? So, and I'm gonna show you what the cathedral looks like. But this is a birth mouse right here, caught. Okay. This is called the heel cut, and this is called the seat cut. Okay. Then they have the tail cut. So all of these have a name. So this cut there right here is the tail cut at the bottom. This is the seat cut and the heel cut. Okay. And then we have at the ridge right here, how they cut it. All right. So this right here is how you will go about that. Let me quickly show you what it would look like if we have cathedral ceilings and we don't have an actual like attic or a ceiling like that. I think this moved. Make sure it's good. Okay. So this guy right here is good. Okay. So what would this look like if this didn't have, didn't have an attic, the way it would look, let me just do an alternative right here very quickly, is that one, we wouldn't have the ceiling joist. By the way, it's funny. This is floor joist. This is a ceiling joist. Same thing. It's just look at it in the different direction. So these guys would not be here. And this would not be here. It's going to be cathedral, right? This guy goes, this guy goes, this guy's go. What we do is that this guy goes, this guy goes, and essentially, whatever this was is now this, and this guy go. But we have a problem. Okay, this guy's tight here, this guy's tight here, but there's nothing tying it here to help it when it's being pulled. So now we need a beam that can help it support the loads. Because before, these ceiling joists was helping it maintain it in balance. You see what I mean? And I'll show you later how they strap them together. This guy gets strapped together to this piece and to the joist. It's beautiful how this is done. It's way more affordable to do this, to do a ridge board because it's way more simpler. Now you have to say, well, wait a minute. This wall is going to be supporting half of this load. This wall is going to be supporting half of this load. This beam now needs to support half of the load. Otherwise, this thing is going to go down. Okay? And to be a little bit more dramatic, if this wall in here is supporting half of the load and this wall in here is supporting half of the load and the ridge beam is not able to support half of the load, this is going to be doing that and that and that and that. Okay? And eventually it's going to just destroy your roof altogether. Okay? So we don't want that. We don't want that to be the case. Does that make sense? So now what do? Well, we have to size an LVL just in the same way that we would size this LVL, but we have to make sure that it counts for roof loads, including snow load at the particular location in which we are. Okay? We're not going to do that right now. So, but let's study how they fasten the roof rafters to the top plates and to the ceiling joists. Connections at roof rafters to ceiling joists. All right, so let's take a look at that. Let's just use none of these ones are showing what I wanted to show you. This one I think is actually not correct either. This is a little bit better. So this is one type of connection on the top plate. You see how this metal also has like an L shape and it goes in. There's different types, but this is one. This is a good one too. You see how they tie in together to the ceiling joist right here? So we need something like that that tightens the roof rafters to the ceiling joist and to the top plate. You see that whole thing? Does that make sense? So these things are called Simpson ties. So there are multiple types, Simpson strong ties. That's a family of ties. Ceiling joist to roof rafters. Beautiful. Beautiful. You see that? Actually, they sell that at Amazon. It's incredible. But that's what I want you to kind of be familiar with. When you're doing some of this, you need to call out some of those items from time to time. Okay, so this is a regular joist hanger. We know those. This is another one right here. Anderson Lumber has this little detail where you connect the truss to the piece. But you get the idea. And it's just doing that. This is the collar. This is like a rafter tie or collar tie right here. But long story short, they basically have a tie that will connect that to that and to that. Okay. One project in which we've used it, it would be nice to look at. Okay. Just gonna find a project in which we did this so that you guys can be more familiar with what that looks like. All right, so this project we're doing a, dormer on, and here's the dormer on this side. We have a beam that's going to be supporting some of the load because it's going to be cathedral, right? A ridge beam. One thing that we want, and this is like a sketch detail, is that the roof rafters get connected to a plate which gets connected to our plywood on the floor. So basically it does these and it flips around and it connects to a plate. So what they ended up doing in this case, guys, check this out. They essentially grabbed an element that looks like a ceiling joist, of course, rotated 90 degrees and rotated 90 degrees. Okay. And they grabbed this guy and connected it here. Okay. And they created a plate. And I'm going to try to model a quick plate just very quickly to see how kind of that looks like. I'm going to make up a plate real quick here. Yeah, I'll have to see how that looks. My bad. Let me see how that looks because I'm trying to figure out the sketch. So it does that and it turns. So this is called Simpson H6. So let's just look for that one instead of me trying to model it. Simpson H6. Here you go. Here you go. So they use them here at this condition. They use them here at this condition. H6, roof, rafter. But it's just really trying to connect one piece of the roof to the wall. You see it, guys, right here? But they didn't have the plates like that to connect to. So what they ended up doing on that sketch was that they were trying to connect to a plate that they put facing down. Okay. You would say, why are you doing that? This is a condition that you are mitigating when you already have this thing built and you're doing this as a repair. Okay, because otherwise, if you're building it from scratch, you have your plate in here, right? And you can tie that to that, you know. But they're not gonna demo these. They're not gonna open this. They said, you know what? Let's connect this guy to our 2x12s that are right here, or 2x10s, and connect it to that. And that will create a rigid connection here so that when this guy wants to go that way, this guy can go that way and can push back. Does that make sense? I hope you guys are understanding.
Yes.
Okay, beautiful. All right, so in this case, that's good. Now, as we're doing this, I want you to be familiar with what comes next. So things that come next when you're building this thing, on top of these guys, we're gonna have our plywood or zip system, okay? For the purpose of this, I guess I can just extrude this guy. And that plywood right here, typically 3/4 of an inch. So we can just probably offset surface, and then say one wants to go one way, the other one wants to go the other way. So let me just do it one and then the other one. 3/4 of an inch. And this other one's 3/4 of an inch. Either the opposite direction, so we're gonna have to flip that. Okay. Now these guys are joined, okay? Don't think that they're not. They are joined. They joined the life out of those two things. So for now, I'm just gonna let it be like these. But trust me when I say that they are joined. If this thing happens to have, you know, like the one that we typically use on the walls, it will have already a air and vapor barrier right on top of it, like a plastic, and that protects everything from like air and vapor going into the building. Okay. Now, a concept I want you to be aware of is that the air and vapor will block air and vapor from going in, but it's like a one-sided thing, because if vapor condensates inside here and becomes, you know, vapor, this air and vapor does allow it to go outside. So sometimes they also call it air and vapor retarder, like meaning it lets it kind of go through, but it also lets it go right out, because we don't want to trap water in any direction. Okay. So now that depends on your location. That depends on where you are. So here in Flow, we just typically call air vapor barrier here, and that's it. Another item that comes after this, okay, another item that comes after this, I've seen some of you guys do the following. I've seen some of you come here and say, and on this case, I guess I'm gonna move this guy up a little bit so that you could see the different layers. Call ice and water shield on entire roof. That's not good, actually, guys. Okay. So I've seen that call ice and water shield the entire roof. That's actually not good. Ice and water shields should not go on top of the entire roof. It should only go at about 3 feet or so off the edge. Ice will not accumulate right here and will not accumulate right here on a roof that has more than 3 and 12, 4 and 12 slope, which is, this is a good roof. Okay. By the way, if you don't know what an ice and water shield looks like, ice and water shield, this is what it looks like. It's a paper, it's a plastic, a felt. And it's always put at valleys, okay, at certain edges, at the edges of the eave. That's where it actually is put. It's not just put in the entire roof. These guys that do it in the entire roof. I don't necessarily recommend putting it in the entire roof. Okay. I do recommend putting it at the valleys and at the eaves at about 3 feet or so. 2 feet, 3 feet. Okay. And that's what this looks like. What is preventing, and we're going to fix that, I guess, right now. What is preventing is that when snow hits the top, let's just put it right here. When the snow, that didn't work. Sorry. When the snow hits this roof and it melts, it will always want to just remain on this spot right here, at these edges. And we don't want it to be at that edge. If it remains here, it's gonna cause trouble with your house. So we just try to protect that layer a little bit more. Okay, so that's why we do that ice and water shield. So that edge right there becomes a little bit more beefed up. Okay, and this thing is typically in black. Just 1 second, let me just color it. And that's our ice and water shield right there. Any questions?
Yeah, I think we do that on our drawings, but I don't think at least I've never heard that we specify how the length of it or where.
We do.
So what's
we should, yes. So
what's the benefit of just, I understood why we put it at the bottom, but why wouldn't it be better to do it completely in the roof just for extra making sure?
just for the same reasons that we don't make every joist out of an LVL to make sure that it's strong. It's overkill. It will be overkill.
Makes sense.
Yeah, so we don't, and you know, as architects and designers, we have to do what's reasonable and prudent, what's proper, okay? And if we start doing things like that, it's not gonna make us, it's not, people are not gonna like us, to be honest. Like, it's gonna be very expensive. We're not gonna be knowing what we're doing. It's just not correct. It's just not right. I can't think of a better answer than that. All right,
I
so
think
that's it. That's it. So then I guess you can mute yourself, right? Then we have, we have our air and vapor barrier with our sheathing. We have our ice and water shield. Beautiful. Something that I have noticed that many of us don't understand is how this detail is created. Okay, how this detail is created. So I'm gonna explain to you right now how this detail typically is created. This is a soffit. Okay, this is a soffit. It doesn't need insulation. That's another thing. We, in our drawings, specify blocking, which gets put right here. It's hard to see because it goes through our walls. So let me just copy it real quick and explain it. But there's blocking that gets put in here in between each bay, okay? And it's cut to length. So at the end of the day, this thing blocks it so that when you're going through here, okay, you don't need to insulate this area right here. That area is not insulated, not at all. But it's cut to length right here, okay? So you have it in between the base. And it's just really blocking the outside from the inside right here. Now, what do? Typically, we have a piece of framing, often made out of 1x, meaning it's just a piece of wood, like a strapping, like a piece of wood. Oh gosh, I'm trying to select this. Let me just get that. Okay, so this guy right here becomes a nailer right here. And they put another nailer like this right here. Okay? And from that nailer, then they're able to attach their soffit panel. Okay, so our soffit panel goes all the way through like that. And that soffit panel, I guess offset surface. Yep. It's about 1/2 inch or so. Okay. That soffit panel gets attached to that right there. And all of this gets caught and at the rake end, this is the rake end. They put a piece of wood to cover it like a cap. But this thing is typically made out of some sort of AZAC or some sort of vinyl or something like that, okay? So it's just a piece of trim. This right here often has a hole to allow for ventilation. So soffit and soffit ventilation. So the air goes right through it and dries out any water that may have gotten inside it. You see it right here? You see that? Okay, so that's vented right there. Okay, so that's vented. Then on top of that, they also put a piece of AZAC trim here. Okay, that piece of trim finishes that off a little, like nice right there. Okay, so that's good. This is kind of the raw version of what I'm trying to tell you, okay? I'll explain more on this in a second. Well, prior to this, often, just so you know, they make this guy a little longer, make it out of 2x, a piece of wood to cover that edge. So I don't want to get ahead of myself. They may use an actual piece of wood on that, and then this guy goes on top of that to cover that baby. Okay. Sometimes they make these out of something a little bit thicker. Okay. Probably not that thick, obviously. But, and they cap that, they cover that. So long story short, they cover that. So you could do that. I don't want to confuse the life out of you. So let's just go back to a simpler version where they just cover that up and we're good there. Okay. And that's your edge right here. And this thing has a soffit with holes in there. And this is that detail. That's like the most basic way that I can tell you or show you that detail. So E section. All right. This is that piece of wood that I mentioned you that gets attached to the wall right here, right? I did another version of this one. Remember where I put another little one? But they on this one didn't do it like that. They actually put an entire piece of wood and then they put two fascias, a small fascia and a bigger fascia. So what I was trying to do here, when I show you this, it was that idea of instead of that, a different one. Okay. So basically what they did on the other one was that this member right here was I don't think I got it the right way. I got confused. Yeah. Oh no, I think I didn't. Okay. Did I do it right? Maybe not. My bad. But I'm gonna explain the point right now. They did this with it. Okay. This is what you saw. And this guy then was more pronounced. Okay. That is this version of this detail. You see it right here, guys? Doesn't make sense?
Yes.
I guess you can see it now side by side. Well, okay. So, and then they put two fascias in there. So they put in one piece and then another piece. So this one will cover the entire thing. Okay, so this one will cover the entire piece of wood. And then they did another little one. And these pieces of trim are, we call it like 1x. We don't say exactly like any size or anything like that. We just say 1x. 1x something, okay? Let me just do a little one here. Okay, here you go. So that's I mean, this is not as good, but that's the whole point right there. So if you see the sketch, that's that idea. Now, one thing I'm missing. So you have your eyes and water shield. Beautiful. That's great. Obviously, it doesn't just float like that, but it's because it's paper thin that we don't show it. One other thing that they do is that they put on right at this spot and on top of it. Let me see if I find a way of getting it. I'm having a hard time with this. Let me just take all of these pieces out of here. Right, so they put something in here on top of the ice and water shield, and they go down with it, and often go behind and it looks like that. That is a piece of metal.
At the dripping edge.
It's called drip edge, but it is a flashing piece. Yeah, you got the right concept. Drip edge is a flashing piece that we put right here, which would be right on top of everything, so that if water gets through, we just get it right out. Okay, so that's so water hits this thing, it goes into this. This one also protects it. Likely our drip edge is actually below the ice and water shield. Okay, so let's see our nice little concept. It's hard to, let me see if I can zoom into it. There you go. You see, like the drip edge right here, and then our or siding right here, and then our plywood right here. It's inside here, and it's just preventing water from getting inside the space. Okay, this doesn't show the ice and water shield on this drawing, by the way, but you guys kind of get the concept. So far, so good. Then, of course, we do our nice our nice shingles right here, or roofing, or final roofing touches. And our final roofing, for the purpose of this exercise, I'm just gonna make it like that. And our final roofing just goes like so. Okay, I can get that one. Let me move this guy. It's finding all the points. All right, so that will be our roofing, which we're gonna paint gray. All right, and now we got our roofing. The roofing, of course, doesn't expand that high above this piece. I'm just trying to kind of make the point and show you the point. Now they do something in here, which is a vent right here. Okay, so it's not always required to have that vent in there. It's called ridge vent, and it's like a cap that they put on top of it. So let me show you what that looks like. Ridge vent. You've seen it right here. It's a cap. It allows air to go right through and dry any water or anything that gets in there, because it's important to have air flow through certain things. It's not always required, but that's one of them. You have to read the code to understand when it's required. I'm not here to teach you when it's required or not right now, but you get the concept. So that's that. Of course, you put your gutter right here, attach it to the wood. So beautiful. Now, the wood doesn't go through this piece. They just cut this piece back, okay? It doesn't go through like that. We've already blocked our space right here. Now we're ready to insulate and get this thing done. And they spray foam insulate right here inside it, and we're good to go. So we have our two scenarios of these, where this guy doesn't have a ceiling. And in this case, just so that I conceptually show it correctly, I'm going to show an LVL so that you guys always remember that this guy would require likely an LVL, okay? Whenever you have a piece like that. And with that, I've concluded my section on how to build the entire framing for a house from the basement all the way up to the roof. Our next session, we're gonna be having more fun with conditions in which we have to calculate LVLs with a void, with a canopy, with an overhang, and things like that. But for now, I think you now are able to build these details generally correct and make sure that they work. The order of these items vary. Like, for instance, this substrate should actually continue up through, and this guy gets attached to the substrate, meaning this is the sheathing that we have outside. So, but I think generally you can build it from here. You can get kind of the idea of how these things work, okay? And if you guys have any questions, make sure to like, share, and subscribe, ask the questions, and we'll see you on the next one.